Hey Gaurav, how are you doing?
Yeah, I'm good. What about you?
Yeah, I'm good. So today's format will be that we will be have a simple problem statement discussion, and then you can, try to answer in generic terms as well as like what you think about the problem statement, right? Starting from the requirements and all, and then how you think it should be solved. So it's basic system design discussion, which you appear for any companies. So we will skip the introduction part. It's fine.
Yeah,
We are anyway done it. Let's directly jump into the problem statement. So the problem is that you might have used a lot of these social media platforms, Instagram, YouTube, or any platform. Okay, so we don't have to design that. What we have to specifically design is that whenever a post is published, okay, or let's say live stream is going on, there is a comments feed there, which you see, right?
yeah.
We have to focus on the design of that system, basically the system which is handling comments, like how those comments are taken as inputs per se for that particular post, or like whatever social kind of media we have, and then how it is like shown to the users, basically. So the system which is responsible for this job.
Okay, okay, fine. So, can I share my screen or?
Yeah, you can share your screen, and we can, you can use any tool for that. So just jot down all the things which you think, and then we can, carry on the discussion.
I've shared my screen. Let me know if it's visible to you.
Yeah, it's visible.
So, first of all,
Can
since
you
we are
close
not,
that Google Meets window, which is
oh
on
yeah,
your
sure.
screen?
So first of all, as we have tell, like it's not specific to any particular social media platform. So I would like to treat it as a standalone service where we are just dealing with the comments and the respective parts like replies or likes maybe. So will that fine?
Yeah, I mean, think it of it as, let's say, for Instagram, like Facebook, right? Facebook has a lot of platforms.
Yeah, yeah,
It has Instagram, it has that Facebook, it has that threads. So let's say you have a comments wala system, okay,
yeah, yeah,
which
yeah.
handles comments for all these systems, because the functionality will be kind of similar with some things here and there, but we can assume that I mean that same system can work for everyone.
Okay, sure. So I'll write some basic features or basic functionalities that could be there in the comment system. So like let me know where I need to add on or uh, where we can modify.
Yeah, sure.
So first thing, a user can first of all that's the main functionality is going to be there. Like user can write a comment, could be on a post or then second I would like to consider is reply on an and third thing could be a reaction on a comment. These three things would be like big part of the comment feature. Is it looks fine to you, or do I need to add more some functionalities that you can think of?
No, I mean, like for a comment system, this is a good starting point.
Yeah,
uh,
sure. Okay. And before that, I would like to discuss like how many comments we are expecting for a day, or how many users we are expecting that are going to comment. If you have option, we can make.
for scale per se, what we can do is we can start with, let's say, pretty small scale, or like
Okay,
I
I
will
would
leave that up to you.
like a 1 million
Yeah, we
user like
can
that.
take 1 million, and then we can think of scaling it further, probably.
Yeah,
So this 1 million is number of users, or like what number?
yeah. It's number of users. It's, I would say daily active users. Now, for 1 million users, let's suppose if you are considering as a um, 50% users are commenting on a post or replying on a post or making some reaction to an comment. So in that case, like the users commenting will be 50 person. So it would be in place of that, I would take it as a 1 million just to use our calculation. So it's 10 million. So our user commenting will be like 5 million per day. Like comments or reaction, I'm considering both in the single form. So let's suppose one comment. I'm assuming it to be a size of 300 KBs, I can say.
Okay.
Then for 5 million comments, since we need to store these comments somewhere in the database or maybe somewhere file system, we could like whatever we are coming on a design part. So for that, our estimate should be like 5 million to 300 KB. So it would come down to
It's fine. We don't have to calculate that actually. If
yeah, yeah, okay,
or you
okay,
can just paste this number in the Google window, you will get the
yeah,
answer.
yeah. So this is going to be our like a basic maybe storage system as well as like the functionality that we are going to have. Now I'll start with the first part that is going to be like API we can expose like add adding a comment like
Okay.
that I could say. Then this API endpoint will get like it would then like we will be having multiple APIs to handle this three functionality. But for now, I'm taking just one, adding a comment. Then it will be uh, connected with the API gateway. That the API gateway is going to work as a redirection part, like redirection also. It's a routing part. So it will be routing this API call to the but to a server which is going to handle this API call. So
Okay.
API gateway is going to be connected through servers. There could be multiple servers because we are handling this much amount of load. So the system should be distributed among various servers.
Okay.
Yeah. So for now, I would take it as two servers. Server now it's going to route based on some algorithm we can use or based on some mechanisms like the server is having which is available to process this request. So based on that, it's going to route that onto that server. Then from that server, we are going to have our we are going to have our next part that is going to be the user. Okay, so for a comment, we need to identify a user. Since it's
Comments will be associated with any post person. Probably you can think of the API structure of add comment, and I mean that would help you to figure out the later components,
yeah,
like
yeah,
how
okay.
the add component looks like
Mhm.
what kind of information you will pass there.
Yeah, okay, fine. Then for that, I would say these servers will have their like the servers will have access to the database. So once we got this add comment request, so server will identify which for which post this request is coming. So in this API call, we will be having some field like as a post ID, we could say, like just to uniquely identify a post, particular post.
Yeah.
So based on that post ID, these servers are going to fetch the post from for that particular post ID, and then this server is going to this is going to be like a one part is going to be the fetch, like it will be fetching the post. Then it will be server could call a different or a next service as a uh, store comment, I could say. So after fetching the post from the DB, it will be calling a different service just to store the comment and map it to this particular post. And then this service is again going to call this same database to store this comment and post. So this is going to be the part where from starting, like it's going to
I'm
happen.
not clear on this fetching post part. Like, what kind of data you are fetching for the post? Like, you already have the post ID.
Yeah, yeah.
What?
So
Yeah.
maybe like it could be a blob object, or if the post is completely a text format, or um, we are having a system, we are having a social media platform that is only having text shareable post. Like we cannot add any images or any media files. Maybe like although it's not there any like there is no any apps that are there which is not supporting media files. So best possible thing is like we could be having the blob storage part. So once it is fetching this post, so it will be returning a blob object, we could say. Like,
No, I mean, what you will do with that information? I probably you are. So the question is basically, okay. So how I understood your flow is that you get a API call that you want to add a comment. From there, you have multiple servers which are handling those requests. Request is routed via API gateway. Then you are fetching the post data, and then you are storing the comment. Okay. But
yeah.
since you already have the post ID, why do we have to fetch the post, like entire post? Uh, do we really have to, like, can we, I mean, is it possible to directly save the data to the post, like whatever database you are having, instead of just pulling the data and then saving? I'm just not able to grasp on the fact that we have to query first. Like, what's the actual use case? Probably you are thinking something and I'm not getting.
Okay. So basically, what I think, just to just not to involve server in this storing the comment part, I am going to create a different service. So what this service is going to do, like it will be first it will be like the server is fetching the blob object from the database, and then the server is going to call this store comment service. So this store comment service is actually going to store the comment in that blob object.
Okay.
So that's what I was trying to reduce the load. Like server should not be busy in storing the comments in the post. It should call a different service. Then this service is going to take the headache of that part. And it could be it's just not be there for comment. It could be for these all these three things. Like whenever we are replying to a comment, so that is also possible in this part only, and reaction also on a comment is possible only. The thing that is going to change for this, like along with this post id, we have to pass one more field as a comment id, just to
Okay.
follow just to make this two functionalities possible, because like reply as well as reaction will be associated with a particular comment.
Cool. Can we work on like little bit on the entire structure of add comment API and like what the response would look like? Let's say I am a
Yeah.
user and I am using this platform.
Okay.
So like if I'm using an app, right? So from app you are making some API call. So what would be the request look like and what would be the response to that add comment API?
Yeah, okay. So as of now, like response, I don't think we need to give any details in the response. We could just give a success or failure response.
Okay.
Uh,
Yeah,
but
makes sense.
the request part, we would be having like a structure somewhat like we have this API where we are going to take first field as a post ID, and uh,
You don't have to write the data type, it's fine. Just write
yeah.
like whatever parameters we have.
Okay,
Post ID,
so
data.
this is going to be the post ID, and
Okay.
I'm keeping like basically two things we can do. We can create two separate APIs, or if we are not going to create two separate APIs, we can adjust all these three features in a one. So I'll just show you both the ways. So if comment ID, like it's about these two functionalities when we are replying on a particular comment and when we are reacting on a particular comment. So in that case, we have to pass the comment ID along with the post ID, so that these two things is going to map with that comment ID of that post ID. So this is going to be the one way. Although we have to make it as a optional field, this comment ID, and at the time of and this API, we are going to check whether this comment ID is present or not. If it is not present, then we are going to assume it is as a fresh comment. And on the other hand, we could also create a separate API just to handle these two cases. So,
Okay.
so like that we can do. We can have a post ID, we can have a comment ID, and obviously the message we can see, the actual reply. Here also we have to mention the comment. What is going to be the actual comment that we are going to make on a post. So like that we can do. And similarly, we could have a separate API for reaction. It could be a post ID, then comment ID, and then for reaction, we could take it as a what's the format of the reaction you can say, like a like, thumbs up, or a smiley.
It will be any byte string only, like whatever data we.
Okay. It's a bytes array, you can say. So these three things we can do. I think we have to keep these three as a separate APIs only. That would be a better thing, because in case of this reaction, especially, we are going to change the data type. So it's not a good thing to merge these three things in a single API. So I would say it's better to keep these three separate APIs to perform three different tasks.
Yeah, I mean, I got the idea on the APIs. Let's, I mean, discuss more on like how you are storing this data into the database. Probably schema, or like what kind of database you are using. Like you mentioned, blob data storage. So I was not clear on the choice. So probably let's have some discussion around it. What kind of database you are thinking, and then how you are dumping that information, or like what kind of query patterns and all, whatever you
Okay,
have.
so for this case, I would say could be a SQL database, or a relational database could be better for this case, because what I was thinking, um, I would I will be creating two separate tables. So I'll just quickly get on the structure. So first table would be like a post that is going to have its ID and user ID, then uh, user ID, put the top object we put that is going to be the actual post content. So this is going to be the first table, and second table. What I was thinking to create a separate table for comments.
Okay.
Here we will be having comment ID. Uh, it will be associated to a particular post. So like that, we are going to have a post ID in that field. Then actual content, like comment we can say. So these two schemas we could have initially, and we also have to store this replies. So we have to reference somewhere in this Mumbai. We have to like we have to reference this replies on the same command.
So in this database, we are storing posts as well as we are storing the comments which are associated with the post.
Yeah.
Okay. And how they are related? The one post ID.
Basically, yeah, they will be related to the post ID. It's a foreign key, we can say.
Okay.
Yeah, I'm just thinking how to store the replies, because reply will be dependent on both post ID and comment ID.
Yeah.
So, and as well as this reaction also. So,
Reaction probably we can skip for now. Let's focus on comments and its replies.
Yeah.
to keep the discussion limited.
Yeah, yeah. So for replies, what I was thinking in this same, if anyhow we can map it to the same comment, map it to the comment part. Uh, let's suppose if there is some maintain. Uh, Post ID is there, comment ID is there, message. Okay. For a comment, we could have a multiple. We could have multiple replies. Um, I am thinking like to create one more table for storing replies, because like it would be feasible if, because one comment could have multiple replies as well.
Okay.
So so to just store multiple, if I am going to adjust the same this replies in this same comments table, so it could lead to data redundancy, because we have to create multiple rows for the same comment if there are multiple replies. So I think like we have to create a
What is the level of replies you are thinking to support? Like like
just
you have comment
uh,
and then you have reply. Can there be replies to a reply or only like one level of comments and reply?
I think only one level of reply I have assumed it
Okay,
till now.
cool.
So if we have this reply schema, again we are going to have a reply ID just to uniquely identify the replies, and then we are going to have a comment ID as a foreign key from the comment table, and the actual reply. So this thing we can say, and the comment. Similarly, we can do for the reaction as well.
Yeah,
If we
that's
are,
I got the picture. I mean, so to summarize what you are saying, you have posts, you have comments, and you have replies. You have three tables, and a post is your parent object kind of.
yeah, yeah,
Comments
we
are
can say
associated to the
it's like a
post,
parent table.
and then replies are associated to the comments which are there. Okay. Yeah, makes sense. So I mean, yeah, that's fine. Now, the other thing which I'm thinking is if some like one is like scaling part of things. Okay. Let's say we earlier started with 1 million users. Uh, let's say our user base grows. So will our same system be able to handle whatever we are thinking? Other thing is around, I mean, failure handling basically. If something goes wrong in our system, okay, let's say comment is lost somewhere when the request was made from API gateway to server. So how will that handling be there?
Okay. So regarding the scaling part, as we are already having the concept of this multiple servers, like there is one API gateway, we could also call it as a, like a load balancer type of thing. Like when it's going to divide the load across the servers that are available in the system. So that's a server part of the API calling or API request part on which we are going to handle the load. And on the second thing, from the database side also we have to take care of the load. So for the database, we could have multiple replicas of this same database. We could like follow some master slave architecture to handle the multiple distributed database type of thing. And yeah, so in that way we could scale this system.
I mean, if we think about normal SQL databases, right, there is a single master and then there are multiple replicas.
Yeah.
So as you scale, you might need, or like there might be a scenario that you are not able to support all the load on single master node.
Yeah. So in that case, master node will only be use for writing or for Yeah, for writing request. And for reading, we are going to rely on the slave or the replicas, because in a comment or in a social media platforms, reading request usually happens to be more as compared to the writing or the request. Because let's suppose out of 10 million users that we are considering in our case, only 10% or 20% we could say is going to create a post, make a post, or make a comment like that.
Okay.
So that way we could uh, think of. And regarding the error handling part, since regarding the database, we are already following the master seva architecture. So in that case, that is sufficient to handle the like if the master node goes down, so the next replica or next slave is going to be the next master node. So uh, that, that architecture is being followed, and uh, yeah, that's the way we could handle the error handling as well. If the
I
system
didn't
is
quite understand. So, like how I'm coming is like I will give you an example. I have personally faced this scenario. Like let's say you are putting a comment on Instagram post, right? And
okay.
then you posted it, and then it is that loader, right? Probably there was some network glitch in your app or something like. Now you are not sure if the comment went through or like it failed somewhere. Do I have to post it again? So that kind of scenario.
Okay. So for that kind of scenario, since that scenario could happen in two parts. One is from the user side, and one is from the server side. So basically, if let's suppose after identifying the particular server, if in between the packet or the command get lost before reaching out to the server, before saving it to the DB, so in that case, we could have some like validation over here at the API gateway side. So just to check whether the request is being successfully executed or not. So API gateway will be checking whether the server is going to store the comment successfully in the database or not. So that is going to be the part that server side we are going to handle. Now the thing is how we are going to handle it from the client side. When from the client side the comment is lost due to some network glitch or anything.
Okay.
So mm,
I mean, yeah, request can be lost
yeah,
anywhere
of
in the
course.
between.
Yeah, okay. So let's suppose we have a client who has commented. Let's put the comment in this system. So if uh, client is having some, we could say, client. Okay, client is going to have its own cache. We can say. So let's suppose if client is not going to mm, all this service. It's okay. Yeah. So. Will be having its own cache the client is going to going to have its own cache.
As
So uh,
in on the application?
yeah, the maybe our web cache or a
Okay,
mobile cache, like that we can say,
okay.
cache memory we could say. So while calling this API or while making the request for adding a comment, it will be like saving it through the cache. Like we are going to basically have the write through cache. So first, at the time of making the request is going to be saved in this cache, and if by any chance we lost the request or we lost the data in before calling this request only, so the we can check whether the same comment or same request is there in the cache or not.
Mm-hmm.
And if it is there, then we are just going to directly call this request from that request that is there in the cache. Otherwise we will be executing a new request. So that scenario is basically when we are not sure whether a comment is executed over the server or not. If it is executed, then it's fine. But if it is not, then we will be checking it along, like although we are checking it into the cache. So we are not going to make the multiple or the duplicate comments. So like that, I was thinking.
Yeah, I think it could be a good approach that you keep reference in your own application or like app or whatever you have, and then you add a comment basically. Uh, yeah, I think it should work. Okay. And on the like, I think you already discussed it, but like if something goes wrong between the servers and database, let's say,
Yeah.
when you are saving the data, so like how will you handle in your application logic, or like how will that servers handle it for storing that data?
Okay. So regarding that, okay. So database it's not going to do as this on. Yeah, at the server side, we could use some sort of like a no that is hmm. Since we could not. I was thinking to use some sort of like a messaging queue or some like the thing, but since it's not our use case because maybe we want real time updates of the comments, so that is not going to work in this case, I think.
Yeah, I mean, you can have simple retries. I was just discussing with you. I mean, we definitely don't want to introduce a new component if it's not needed. Yeah, okay. And we can have simple retries per se.
Yeah, yeah, that's
Okay. Like clear on these things. I just want to discuss like focus for like let's say 5 minutes on delivery part of comments. Okay. So let's say this is adding comments of things. Okay. You are adding comments on a post. Now we also have to think on like people are reading those comments, right?
yeah.
So how will that part work?
Okay, so for that, let's suppose this same user wants to get the comments. So it will be again going through the API gateway, then servers. Then instead of calling this service in between, which we were calling to store the comments, we'll just directly fetch all the comments for that particular post, and we'll returning it to the user.
Okay.
And of course the as we are following the master slave architecture, so the read request is not going to be processed by the master node, it's going to be processed by the replicas.
Okay. And what if there are a lot of comments? Like let's say this is a post made by some famous user. So there
Yeah,
will be a lot of
so
entries.
in that case, we have seen in the real world chat applications or in the social media platforms, we got the one options of load more comments. So basically, they do the pagination thing, like they process or they fetch the comments in chunks. They didn't fetch the comments all at the once. So let's suppose 10 comments at a time. When the user clicks on load more comments, so more 10 comments will come. Like that, we can do.
Okay. And like okay. I mean so the idea is that the users will have some sort of get comment API,
Yeah,
and that will be used to fetch whatever comments are there for this particular post.
yeah.
Okay. Uh, yeah, I mean, and there will be some sort of pagination in your application that if there are comments more than particular threshold, then they will be paginated and they are routed. I mean, there will be a new request from an actor or this user that give me more comments on this post, something of that sort.
Yeah.
Okay, makes sense. Yeah, I mean, this is all I wanted to discuss. Yep, cool. So, I mean, since this is a mock interview, I will just share like a few feedback around it, and then we can close the interview. That should help
Yeah,
you as well. Okay.
yeah, yeah.
So I kept some notes on the architecture and like how you started with the problem. So first thing is like you definitely did a good job. There are some the best thing was that you did trade-off analysis at multiple places, which is a good thing to do in systems and discussion. One was that around the API design, like should we have a single API or should we have multiple APIs, right? So that was one. I think you had that at one more place as well. Uh, so that's good thing. But on the feedback front of thing, what I would say is that on the requirement section, you could spend some more time around it, okay, and then try to understand because the these kind of systems, right? They are very read heavy and like less write heavy, okay.
Yeah, yeah.
So that requirement should come in as part of, let's say, probably non-functional requirements per se when we have that initial discussion. So you can have those functional requirement discussion that these are the features I'm seeking and what kind of non-functional requirements make sense to me. Okay. Another point is you discuss scale. That's good thing that these are the number of customers we are thinking and this the storage we are trying to use. I would suggest that if you are doing a storage calculation, uh, we should I mean justify on our storage choice as well that this was my storage. Okay, this is the storage capacity I needed. And if I'm using, let's say, SQL database or like whatever choice database choice I'm making, why that database choice? So is storage a contributor? Okay, so that's one thing. Then I think, yeah, I was pretty confused around the store command service. Like you have multiple servers, and then why do we need a separate store command? Uh, I would probably simplify it to just have a single component, which might not need to store, like retrieve the post uh, and directly dump it to the database because you know that post will exist. So you can, because it's not an immutable object, you can just, it's a mutable object, so you just append the comments to it. So that's one thing. So I thought that could be that would add a complexity here. We could be simplify somewhere. Uh, like, and on the one part we discussed at last, right? Like handling read part. So since the system could be really read heavy, and for celebrity users it will be really read heavy.
Yeah.
So we have to introduce some kind of mechanism so that we are not hitting the database probably. Okay. Uh, we introduce some sort of caching. Uh,
Yes.
we definitely have read replicas, but again, if it's a celebrity user, you will introduce a lot of load there. That's one thing. Another thing is we can also discuss, think on architecture where instead of user pulling the comments, you can from your like backend system, you can deliver the comments to the user application. So that's another direction. But yeah, I mean that comes at later point. First thing is we can think on some level of caching in our architecture, like and like the caching which you introduced to store the comments, right? That was pretty good. Uh, where you thought on that you will have some sort of application cache, and this is heavily used in like all the social media platforms. So that was good point which was brought up by you. This is also used for like timelines and all those sort of things. So that is really good thing that you came up with. uh yeah, on the database discussion, I have like one feedback that instead of directly suggesting a database, you should think on like first think on what are the kind of query patterns you want to solve. Let's say you want to store the data, what will your read queries look like? Okay, and then depending on that, you make a decision. Uh, like this is the database which makes sense to me, and there could be other factors, but yeah, this is the good starting point. That yeah, these are my query patterns, and like storage was one thing. So some of the factors, and like let's say you are suggesting SQL, are we using some properties of SQL databases, let's say handling relations? So you mentioned that there are relations on post, comments, and reply and all, but you should mention it that yeah, because since there is some relation, we might be able to use join queries or those things. So yeah, and caching was good thing which we discussed. Comment delivery we already discussed. I think you might want to think on this API gateway as well. Like we are trying to do load balancing via API gateway, which might or might not be supported. So, I mean, these days it's kind of a mix that API gateway supports functionalities of load balancer and load balancer supports function. So you are not wrong there. But yeah, you should mention it. That would be a good point to mention to an interviewer. So,
Okay.
yep. I mean, these are good of good. I think you got what good things you did and what are the things which can be improved. In the end, it's a design discussion, so there is no perfect answer. Uh, it's like wherever the discussion leads to us. So overall, it was good. Yeah.
Okay. I have one question. So let's suppose the same question has been asked to you for the database. Like, how would you choose a database, or for this, which one should be the better choice? So, how would you start it? Or how I can start it better?
So my general approach is like as I mentioned, right? I do not go to database choice directly. My thinking always starts from what is my expectation basically, because we start from the requirements, right? So what is my expectation? What is the kind of data I want to store? Okay. So I know that I want to store comments, posts, replies, and all. So that's one thing. Then I should have clarity on the query patterns. Okay. Because in the database, we generally tend to, I mean, most of the systems are read heavy as compared to writes. Okay. And this system is really very read heavy. So somehow we want to optimize on that reading part. So what are the read query patterns I have? I want to get the comments, okay? I want to get the replies of those comments. Like so these are some of my query patterns. Now storage was another angle. Then scaling part of things that comes later. But yeah, I mean I will definitely start from the requirements as in what are my expectations, as in what are my query patterns, read and write. So that's the good starting point. And then you can, if you are thinking around like SQL and NoSQL, right? That's a general, I mean, discussion you will see in multiple interviews as well, because it's available all over the internet. So
Yeah.
you might have that comparison. So I would suggest, because there is a thin line between like these databases these days. If you see non-relational databases, always there multiple of them support ACID properties. And if
Yeah.
you see SQL databases as well, there are like lot of databases which offer horizontal scalability. Like in case of Amazon, Aurora D SQL is recently launched, and I think there are a couple of open source softwares as well. So yeah, I would definitely start with the query patterns and what kind of data I want to store and how I can optimize my read or write. In this case, read specifically.
Okay.
Okay. Cool. I mean, yeah, it was great connecting with you. I will
Yeah.
stop the recording and we will continue.